Hey guys, welcome to the channel. So we're going to be solving another question from chapter 6 of Johnston textbook, question 45, and we have a Warren Bridge truss that is loaded as we can see in the figure. We need to determine the force in members CE, member DE, and DF. So as we can see, the question is asking for specific members. So we're going to go with method of sections as it would be easier option compared to method of joints, and it will be faster too. So the section that we're going to pick has to passes through these members, which makes sense to do a section like this. And we can go either with the half, the left half of the truss, or the right half. It seems to be easier to go with the left half. But before that, we have some unknowns at two supports of A and K. So if we look at A, we'll see that we have a roller, meaning we have more freely in x direction. This is our x and y, so no x component at A since there is no friction, and we're gonna assume that there is no friction because we don't have any information in the question. So at K we have a pin, meaning we have both x and y components, so kx and ky. So we are in equilibrium. We're going to use our equilibrium equations, which are sum of all forces equals 0 and sum of all moments about any point has to be 0 too. Here we're going to start with sum of all forces in x direction. The only force in x is kx, which means this force is 0. And one thing that we need to keep in mind is that although we can see that the truss by itself without the loading is symmetrical, but as we can see, the loads are not symmetrical. There we have a 6,000 pounds force at point C, so the truss is not symmetrical, and our A will not be same as KY. So in that case, we're going to go with our moment equation. We can do either at point A or K. That way we can get rid of one of the unknowns. So if we do about A, we have the moment of KY, which as we can see is in this direction about A. So counterclockwise, it will be a positive moment, ky times the distance. We have the distance from A to K, which is 12.5 times 1, 2, 3, 4, 5. And we have two 6,000 forces that are making clockwise moments. So negative for both. One of them is 6,000 times 12.5. The other one is 6,000, again negative sign, 12.5 times 2. And this will be equal to 0, and we can figure out our ky in here. So we can cancel out 12.5 in each of these. So what we're going to get is 5 ky is equal to 6,000 plus 2 times 6,000, which is 12,000. So ky would be 180 divided by 5 is 36, and we have two zeros, pounds, no negative sign. That shows that our ky is in correct direction. So now that we have this, we can use our fy in order to find the A. We have A plus ky minus 6,000 minus 6,000. This will be equal to 0. So ky we figured out is 12,000 minus 3,600, which is going to be 8,400 pounds. Again, no negative sign. The direction was correct. So now we have all the unknowns that was missing at the first place. Now we can draw the free body diagram of the left side of the truss, which is something like this. So we have 6,000 here. We have our A, which is 8,400 pounds, 6,000 pounds. And we have three different members that are attached to this point. We can pick any direction that we want for now. Let's just go with this. For now, if we get the negative sign at the end, that shows that the direction was incorrect. So we have A, B, C, D, and if we continue these two, we'll get to the point E. So this member is FCE, this member is FDE, and here, the right point here, we have F, so this force is FDF. All right, so since we have the most unknowns at point D, it makes sense to start with finding the moment about point D. That way we can get rid of FDF and FDE. So we have the moment of FCE. As we can see, the moment about CE is in this direction, so counterclockwise positive FCE. And the distance that we are looking for is this distance in here, which is 15. So we have that in the question. In the figure, we have that information. So we have the moment of 8,400 pounds, and the moment is in this direction, so clockwise will be negative 8,400 times the distance would be, let's get back to the truss. The distance would be from here to here. So it's the vertical distance to the line of action, 12.5 plus 625, which will be 18.75. And we have the moment of 6,000 pounds counterclockwise, so positive 6,000. And the distance this time would be, this is the vertical distance. And we are looking for, I'm just going to clean up the previous one. And we are looking for from here to here, which will be what we have in here, which is 6.25 plus 12.5 minus 12.5, which is going to be 625. So times 6.25 is equal to 0. And here 15 FCE would be equal to 8,400 times 18.75 minus 6,000 times 6.20. So if we calculate FCE, we have, so 8,400 times 18.75 minus 6,000 times 6.25. We're going to divide that by 15. That's going to give us 8,000 pounds for FCE. Let's figure out the member's in tension or compression. So the member is somewhere in here and has to be in the opposite direction, so we'll be in tension. That's the first unknown in this question. Let's move on to the second one. We should be able to find the FDE if we do the sum of all forces in y direction. So we have 8,400 minus 6,000 minus the y component of FDE. Let's see how we can figure out the y component of FDE. So for that, we need some information regarding the angles, and we would be interested in this angle here. So we know this part in here is 12.5 divided by 2, or 6.25, and here we have 15. If we call this angle alpha, we can find the alpha by doing the tangent of opposite over adjacent. So alpha would be the tangent inverse of 6.25 divided by 15. So let's figure this out. Tangent inverse of 6.25 divided by 15. It's going to be 22.62 degrees. And here the y component is alpha, would be cosine of alpha. So cosine of 22.62. That's pretty much all the forces that we have in y direction. So FEE would be 8,400 minus 6,000 is 2,400 divided by cosine of 22.62. Let's calculate this one. 2,400 divided by cosine of 22.62. That's gonna give us 2,600 pounds. And let's go figure out if the member is in tension or compression. So here's the member FD, it has to be in the opposite direction. So this one is also in tension. And the last member that we have is the FDF, which if we go with sum of all forces in x direction, we should be able to find that. So basically we have everything to the right, FCE plus, so sum of all forces in x direction, FCE plus FDE. This time the x component would be sine of alpha. So I'm gonna show it in green the way I'm dissolving FDE. So this will be the y component and this will be the x component. So cosine, this will be the cosine, and the other side or the horizontal one would be FDE sine of alpha. So this one FDE cosine of alpha. And all you need to do in here just to pick this right triangle and find the cosine of alpha and sine of alpha, and you get to these two. So if the sine of alpha and the last one would be FDF, which is the last unknown that we have. So FCE we figured out from the previous part 8,000 plus FDE sine of alpha 2600 times sine of 22.62 plus FDF. So we're going to get a negative sign for FDF, which shows that our assumption was incorrect. So 2600 times sine of 22.62 plus 8,000. So that's going to give us minus 9,000 pounds. So the direction is actually in the opposite direction that we assume. So this is the correct direction. So if we get back to the member that we have in here, it has to be in the opposite of that. So this time the member is in compression. So watch out for these negative signs. And whenever we get this, that shows that our assumption was not correct. So yeah, that's the final answer for this question. Hope everything was clear and everything made sense. Let me know if you guys have any questions. We're covering 3 different textbooks in this channel. Feel free to check out the playlist and let me know if you have any specific problem that you want me to solve it in the next videos. And you guys take care. I'll see you in the next one.